This is what we are working to find. But there is a rather lofty set of random circumstances that have to coincide in order to make the oil and gas we explore for. The Utsira High has been a focal point for us in Lundin over the past few years. This is where we discovered Edvard Grieg and Johan Sverdrup, among others. But the beginning of this adventure goes back around 300 million years. Back then, the Utsira High, which is now located 2 kilometers under the seabed, 200 kilometers to the west, was the Utsira Island, situated approximately where we find the Middle East today. A nurturing climate for algae, microorganisms, and a whole lot more. This was all deposited and buried in the sediments over a period spanning many millions of years. This is the first piece of the puzzle needed to end up with an oil reservoir. Biomass that doesn't break down with oxygen, but is buried without having a chance to rot. Next, several million more years must pass to allow these sediments to sink so far down that they achieve the pressure and temperature necessary to form and release the hydrocarbons. This yields source rock, or the kitchen, as we geologists like to call it. These hydrocarbons are in motion. Slowly, inexorably, they are pressed across, inward, upward. This is a continuous process and a dynamic system. Now we need a trap. In simple terms, an upside-down bowl made of impenetrable rock. The hydrocarbons fill the bowl down to the rim. Then it's all up to us to find them. Easier said than done, unfortunately, which explains why optimism is an essential quality for exploration geologists. There are locations in both the North Sea and the Barents Sea where we see gas leaking straight up from the seabed, and we have found carbonate crusts deposited from such natural gas leaks. These also become pieces of our giant puzzle. We put together a few more pieces of the puzzle by acquiring seismic data. Seismic technology is constantly improving. In Lundin, we have established what one might call a seismic laboratory in the North Sea, in the form of a datum line over the Utsira High. Most of the available technologies have been tested along this same line. This gives us an excellent opportunity to compare data. And both quality and resolution have improved vastly over the last 10 years. The latest addition to this technology is TopSeis, a new method of collecting seismic data that we have developed in cooperation with the geoscience company CGG. 2 seismic vessels work in a tandem operation. By placing the signal source of one of the boats directly over the cables instead of in front of them, this yields more signal reflection than with conventional seismic acquisition. This allows us to examine the subsurface with 10 to 15 times more signal energy. TopSeis gives us a detailed and quantitative depiction of the reservoirs and is particularly well suited for relatively shallow oil and gas fields like those in the Barents Sea. This will reduce the risk associated with drilling and improve the chance of finding oil and gas. Seismic tells us a lot about where we can find hydrocarbons, and metering instruments in the exploration well give an indication of what we will find down there. However, there is no certain answer until we bring up a sample of the reservoir rock.
Log measurements can be wrong, and that's what happened when the drill bit reached the top of the reservoir of Edvard Grieg in 2007. No reservoir, no oil was the log readings. It is a dry valve. Fortunately, the geofundamentalist in Lundin said, no, this can't be right. There is something wrong. We need more data. We need the core sample. We need to go back down there. There is something here. Hey, Norway's most expensive piece of rock. It cost us a few millions to get this. Then again, it could be Norway's most profitable, because when we analyzed this, we found both reservoir and oil. The Edvard Grieg field was found. For us in Lundin, it's really important to take cores because we found them necessary to get the data we need. But the cost is a limiting factor, at least up to now. Have a look at this.
Using a tool called Intelligent Coring System, we can take core samples whenever we want, without having to pull the entire drill string. We can take readings on the sample and assess whether or not to keep the core sample. If it's interesting, we save it in the chamber located above the drill bit. If not, we just drill right through it. If everything looks good up to this point, we have a reservoir. Then it's just another 8 to 10 years until we can start production. First, we have to understand the size of the reservoir and its properties. Several wells must be drilled to find the answers, and we have to start the work of selecting a production facility. Can we send oil and gas to an existing platform or production ship nearby? Is the water depth so great that we have to build something that floats? Water depth at the Edvard Grieg field is just over 100 meters, so a platform can rest on the seabed. However, a development requires substantial capital. We are approaching the moment of truth, the moment which gives the economists a few sleepless nights, the investment decision. Should we put 25 billion kroner on the table? Yes! For some, the job is already done. For others, the work starts here. The platform will be a workplace for many people, and it's all about safety. Safety for people, for the environment around us, and for equipment and material assets. We have systems that monitor every aspect of the production, and highly skilled people who monitor the systems.
And all these skilled people need to be as prepared as possible. That's why we spend a significant amount of time on planning, exercising, and training.
We have a simulator room that is identical to the control room on the Edvard Grieg platform. Here, the process operators can practice and test the systems without adverse consequences. We can't do that offshore. We simulate ordinary operation and production, and the operators can practice handling unforeseen incidents. An oil platform requires continuous maintenance as well as periodic modifications. This work is planned by the operations group. We have a 3D model where we can view the various areas. We can look at individual components such as pipes or pumps. The model provides information about every single bolt, seal or nut. And we also get a visual idea of how much space we have to work with. One of the most important things we do is talk to each other. We have a video conference with the people on the platform every single morning, where we review the activities and the work done over the past 24 hours and what is planned for the next 24 hours. And that is how we will work for 20 to 30 years. It's about maintaining high and stable production. We need revenues to justify our investment. So where do we go now? Ever upward, of course. We have done a lot on the Utsira High in the North Sea. We have started to study the possibilities on the Frøya High in the Norwegian Sea. We have made several discoveries on the Loppahai in the Barents Sea, and we will take part in the exploration of virgin areas further to the east and north. The Norwegian shelf will be a source of employment and income for at least a couple more generations. Probably more.